Hi, today I'm going to give you kind of a whirlwind tour of functions in a spreadsheet. Now these particular functions apply to Google Sheets, but what you'll find is that these functions are pretty much available in any spreadsheet. The package of functions is generally similar. There may be slight differences in the syntax of some of the functions, or maybe an extra one or a lesser one in a different spreadsheet, but by and large they're very, very similar. Okay, and the way we're going to do this, because we're going to go through a lot of functions, as you can see, these are text functions. There are statistical functions, there are math functions, there are logical functions, there are lookup functions, there are info functions, and these are not even a complete set of functions, nowhere near it. These are just some of the most common and useful ones that I've found. So to avoid making this video 2 hours long, what I'm going to do is I'm going to give you a quick overview of what they do, and then I'm going to show you a sample of a couple of them. Okay, so let's get started. The first one the first set of functions are text functions. Concatenate simply means to join together. So if I wanted to put two pieces of information, like the first name and a last name, into one cell, I could use concatenate. Exact simply looks for an exact match. So you can compare two fields. If they match, it gets a true, and if they don't match in any way, it gets a false. Find is going to return the position of something you search for. So if I search for a dash for all of these fields, I'm going to find it only in number 4 here, this Wallace Green, and it's going to give me the number 1, 2, 3, 4, 5, 6, 7, the 8th position. Now that might seem kind of tedious, but it's actually very, very useful to be able to find these things, because we can then use other functions to kind of pull the strings apart and reassemble them, etc. Left returns a particular number of characters from the left side of the string. So generally you want to use that with some other function like find. So if I found this @ sign, it would give me the position, and then I could just take everything to the left of that to pull off the domain name and get just the username here. Okay, length gives the overall length of a string. Lower converts everything to lowercase, so if there are any capitals, it takes it away. Mid returns some actual characters from the middle of a string. It can be from the beginning, but generally it's from the middle, and it will just take a piece of that string and return that to you. Proper puts things in proper case, which is initial capitals, like a title case. So lower and proper are similar. One puts it all lowercase, one starts everything with a title. Replace allows us to substitute one character or set of characters for another in a string. Right is very similar to left, it just pulls from the other side. Trim pulls off spaces before or after a string. So if you were to look at Jane here, you might notice when you clicked up here that there's a trailing space, and this is not uncommon, especially if I've gotten my data from another database and brought it into Sheets, or if I've copied it from the internet. Sometimes I can pick up those trailing spaces, and trim will take care of that. And then upper is just making everything capital. So let's do a couple of things with this and see how it works. I want to create a full name in here. So I'm going to use concatenate. Let's keep in mind that for a name to be correctly displayed, there would need to be a space between the first and last name. So I'm just going to say equals concatenate, and I'm going to take the first string, which is A. Now I can put a space in here if it makes it easier for you to read. This end is the concatenate sign. It's going to say take what's in A to end. Now I'm going to put a space in there. And the way to put in a space is to put a quote, space, quote, and what's in cell B2. And there you go. So now I've got my John Smith. If I drag it down, I've got all of my names. Problem here is that, see that extra space shows up in Jane Doe. So one thing you can do is you can wrap functions in other functions. So this is getting me what I want. I could make another column here and just say simply trim the value to take out the space, but what I want to really do here is demonstrate that you can put think of this as a quantity, so, and then use another function on it. So I just wrap the whole thing in parentheses, and I put it inside this trim function. And now when I drag down the updated formula, I'm going to get rid of that double space in here. Okay, let's use a couple of these functions to create a username. So to start with, my username pattern is going to be first initial of first name, the entire last name, everything lowercase. And let's try that. We're going to say equals. Now we want the first letter of the first name. So what I'm going to do is I'm going to say I'd like left. Next thing is the cell number, so I'd like whatever in A2. I'd like the left piece of that. And when I put a comma, you can see it gives me my instructions right here. So it's saying number of characters. And I'd just like the left one character. Now, it would be possible to substitute another equation for that one if we needed to calculate it. Let's keep this fairly simple. And you can see that gets me the J. Now, I thought I wanted everything lowercase, so we'll get to that in a minute. But the first thing to do is to concatenate the last name to it. Okay, you see I'm getting close. And now if I take that entire thing, put it in parentheses, type in lower. And there you go. Here's a username. Now, feel free to do this in stages if you want in the beginning. And what I mean by that is, I'll do it down here so we can just preserve this. If I were to say equals left first name, comma 1, notice that whatever parameters you send into one of these functions, the way it's going to know it's on the next thing is by separating them by commas. So there's the J. Then I could actually say equals this and this. There's my J Smith. And this equals lower case of this. Okay, so I got to the same place, and what I did is I just did it instead of getting this formula, which in the beginning could be confusing when you're first working it out. You can build it a piece at a time if you want. That'll get you more familiar with the functions and what they do, and you can always substitute them back in. Just, you know, copy one formula into another formula to get it to work if you want to make it a little less visually cumbersome, you know, fewer steps. Okay, and to create a district email, that would be easy. I would just say, please give me this, and now I'm going to put it in quotes because I'm adding this as a string, at email, no, I think I said it was going to be at myschool.com, close the quotes. Okay, so there's my district email. And this is the email I started out with, something that someone else submitted. And let me put in one more. Just one more function we want to look at. Is the district email the same one they submitted? So I just want to check for that. And I will say equals exact. String 1 is going to be the one they submitted, comma. And string 2 is going to be the one we created, and that's going to say false. Okay, so in this case, you can see that they all say false. So let's give that a visual check to see if my formulas are working correctly. Okay, this is jsmith@myschool.com. Oh, this is jsmith@email.com, so they don't match. jdoe@myschool.com, jdoe@myschool.com, that does seem to match, so that shouldn't say false. Check that in a minute. mwallace@myschool.com, oh, mwallace-green@myschool, so that should be false. And mcflyer@myschool.org, mcfly@myschool.com, so that should be false, but this one should match. And the reason it doesn't is because it got this extra space in here. Remember, when we created this, we took this value, username, and we appended the domain to it. Now the problem is that while I made JDomain lower, this one pulled from Jane Doe, and Jane Doe had an extra space in it. Remember, I used that trim function over here to take it out of full name, but I never did that with username. So let me do it now. Just add it into the formula. I'm taking that entire thing that I had previously and wrapping it in a trim function. And that not only fixes this, but it fixes this. It makes it true. Okay, now look at what we have here. We have a concatenate function in here. We're taking the left one character plus this. We're making it all lowercase by wrapping it in this, and then we're trimming off the extra spaces by wrapping it in this. So this is just to demonstrate that if you want to, you can make these formulas rather complex. However, you can build them out stage by stage if you'd like as well. Okay, lots more you can do. These are very, very useful functions. Let me just do a quick one on find equals find. And it's, what am I looking for? I'm looking for the @ sign. And where am I looking for it? I'm looking for it out of this particular email. And you can see that that's the 7th character. And you can see that it's in different positions depending on the length of what's before it. So this is very common. You can use that in combination with left or right or length. Length would get you the overall length. Let me just do that down. Make one more row here. So that's the @ sign. This is the total length. And that's just a very simple one, equals length of this email address. The total length is 16. You can see, of course, it's going to vary for every email address. And you can use this find function in conjunction with the left, the right, sometimes mid, various other things to extract particular information from strings. Okay, so that might be more information than you actually wanted, but the more you play with those things, the better you get. Let's go on to some other functions. Okay, statistical functions. Okay, these are ones that we're used to, like average and median and minimum and sum. I don't have sum here, but that would be fine. And we also have some you might not be familiar with. These count functions and these count if functions and this large and small. So let's take a look at those. First of all, the average would be easy. I would simply say equals average and pull these across. Great. So there's an average of 89. If I drag this down, you're going to notice that the average, let me just change that. I'll explain that in a second. I can just see that the average is going to ignore missing values. This 86 and 81, 83.5. Even though this doesn't have a numerical and this one's blank, it just ignores them and uses the numbers. So that's smart. One of the things I'd probably like to do here is, set those up in a consistent way as far as decimal goes. Now, if we're looking for the highest score along here, I might do something like max and get that same range. I don't want to include my average, even though my average would never be the max. Oh, I forgot to put the equal sign. So it's a common mistake. If you do that, nothing's going to work. So there you go. So my highest score is a 95, and in fact it is. So I can use this small amount of data to do a visual check to make sure things are working. Yep, there's the 99. This one's an 86. This one's an 82. It's working perfectly. Lowest equals minimum, and that's MIN, and the same data set. making sure not to get the average or anything, and that'll just get me my minimum value here. Okay, no problem. Now, I could do the same along the bottom. Equals max wrong parenthesis. I'm actually just going to drag, no, I'm not, equals min, and the same thing here. And the difference between these, the min and max I did in column G and H, and the ones I'm doing, those really don't make sense. Okay, the difference between these and these is these are personal. So this is John Smith's highest and lowest. This is the class's highest and lowest. So good information. Now, let's look at some of the other functions, and I've set up a section down here. So the number of expected grades. Okay, let's take a look. We've got count, which will count cells that contain a number. Count A, which will count cells that are not blank. Count blank, that will count cells that are blank. Count if, that will count cells that meet a certain criteria. Count ifs, that will count cells that meet 2 or more criteria. Now we've also got large, which will return, we can give it this nth value. So we can say, give me the largest, the second largest, the third largest, etc. And small works the same way. The smallest, the second smallest, the third smallest, etc. So let's get started using those. For expected grades, I'm just going to say that I have 4 students and I have 4 tests, so I'm just going to enter that manually and say 16. The total grades, these are the total grades I already have, so what I want to do is I want to count the cells that contain a number. I want to exclude, well, one's capital and one's not that it matters. I want to exclude the ones that I've exempted and the ones that have not yet been recorded. So maybe somebody's got to do a makeup. So for total grades, I'm going to use equals count, and I'm going to select that block of cells and say enter, and there are 13. Okay, the total missing, I'm going to try count blank. Okay, and only 1 is actually missing because 2 are exempt. Highest score, I simply could use a max here equals the maximum of this entire block. But let's see, I also want second highest score, third highest score. You know what, maybe I'm going to change that. Maybe I'm going to come back here and say I'd like large. I'm going to put this block in here, comma 1, the largest score. Okay, that's a 99. Now, I want to get the second highest score, but I can type the whole thing again if I want, or I can copy this down and just change that to 2. The issue here, and you've got to be careful, is that this is referencing cells B2 to E5, which is always what I want to be referencing with what I'm doing. These are my test scores. So before I copy this down, if I'm trying to do that to save time, I'm going to come in here on B2 and I'm going to add $signs in front of both the letters and numbers of both references. Okay, that's just going to remember those absolute values, it's going to lock in those values. So now if I drag this down, well, it's going to copy the exact same formula, so it's going to give me 99. But if I swap that out for a 2, I guess my second highest score was a 98, and I swap that out for a 3, now I'm going to get a 95. Now another little trick I can show you for copying is if I clicked here and dragged down, I would get this formula here. I would get the formula that's in B14 in all 3 of these. But if I select all 3 of them and I copy down, it's going to copy that pattern. So you can see that now it's copied the formula from the highest score into the lowest score, from the second highest into the second lowest, etc. Now, of course, that's not what I want, so I want to just change this large to small. Now, I'm showing you that just as an approach. I mean, if you don't want to do that copying. If you find it easier to do it another way, either start from scratch each time or little mistype there. So if you don't want to do that, that's fine. What you do want to do is just know about it so you know what your options are. Perhaps you can save your time, save yourself some time. Now, next three are looking for the number of scores between certain ranges. Okay, so this is something that I could use count ifs for, because I'm going to need two criteria, 60 and 80. So equals count ifs with an S, and we can see that basically it's looking for a criteria range. So I can do this. That's the data I want to deal with, comma, and now it's looking for the criteria. So I am going to say here, I want the values that are greater than or equal to, I can put those together, 60. Now let's see if that works first. It's counting 16 of these values that are greater than or equal to 60. But what I really want to do is I want to be able to apply two criteria. So greater than or equal to 60, if I put another comma, it just lets me list another set of data. So I'm going to, do the same set of data here. And this should be, and I'm going to put this in quotes, less than or equal to 70. So in here I have one score between 60 and 70. Let's see, there's a 68. And that is the only one I see. So it's doing that accurately. Now, between 70 and 80, 80 and 90, and over 90, I would in this case definitely use this formula. I've done too much work. But I have to remember to lock in those cell references. So I'll do that here and I'll do that here. That'll save me some time. Now all I really have to do when I copy these down is come into 70 and 80 and say, you know what, it's got to be greater than or equal to 70, less than or equal to 80, and this should be 80 and 90, and there's 5 of those. Wow, I must have had a lot of students who did very well, scores over 90. Now here's an example. I can use a simpler formula. I can just say equals count if, because I'm only doing one criteria, this stuff is greater than or equal to 96. And if I wanted to do a check, remember I have 13 total grades. Let me just come over here and I'll do a quick sum of the number of cells that it found, and that equals 13. So logically that makes sense, unless of course I could have had a field here for under 60, but luckily I had no scores under 60, so it worked out okay. Median score. Median is just what it sounds like. It's the middle score. So it's another type of average. Instead of doing an average of all these scores, which I could have done, I'm going to find what the middle score is. Again, it's going to ignore blanks and irrelevant text. And the middle score, if I put these in a list, is 88. Okay, so you get the idea. Statistical functions, these are really good to know. These are things you might want to work with your students on. And getting familiar with these count functions is really a good idea. They can be very helpful. Okay, let's look at some math functions. We're going to do this very rapidly. Okay, this is to get an absolute value of a number. This command rounds a number to its next even number. This returns the integer part of a number, which may include decimal, but it's just going to return the first part, the integer part. This determines the least common multiple. There's a log function for getting the logarithm of a number. based on its base. So we count a base 10 system, but there are other bases you could use. Modulus is the remainder of a division problem. So it doesn't get you the answer, just the remainder. Okay, odd rounds to the next highest odd number. Power is just the way to do exponents, 2 squared, 2 cubed, etc. Random and random between we've looked at before. Round rounds it to a particular decimal place. So I can say round it to the 10th, the 100th, the 1000th. Whereas round up takes it to the next value, next higher value based on a decimal place. So you can say 23.2 is going to round up to 24 as a whole number. So it's just going to take the larger one, but you can do it to a particular decimal place as well. There's a function to get a square root. And these three functions, sum, SUMIF, and SUMIFs, if you remember the COUNTIF and the COUNTIFs, they work the same way. There's also an average, AVERAGEIF, and AVERAGEIFs. It just lets you add criteria into the equation to decide on what's going to be, in this case, summed or averaged if you're going to use that function. Okay, to save some time, I'm going to put in some values here very, very quickly, and then we can talk about them. Okay, a little magic there. If I click on this, basically this is the absolute value of this cell. I'm going to take all my references from either A or A, B, C, whatever is relevant. So the absolute value of negative 23 is 23. In this case, the next closest number rounded up to even of A3 is, 156 is 156. However, if I made this 151, it would return 152, and that's the next higher even number. This returns the integer portion, so the 44 from 44.67. Least common multiple of 3, 2, and 9 is in fact 18. This is a logarithm of 11 in a base 10 system, but if I was using a hexadecimal system, say base 16, the log would be different. Or if we're using a computer-based system such as, jumped out of that cell, computer-based system with a base 2 system, you can see the log is very different. Okay, this is the remainder. 23 divided by 9 does in fact have a remainder of 5. This odd function works exactly the same as the even function. It's a 52, so it's giving me the next higher odd number. But if I were to type 53 in here, yeah, it would give me 53. Okay, this is power. So in this case, I've taken 2 raised to the second power, or 2 squared is 49. But if I raised it to the third power, 343. So that's working accurately. You may notice that these numbers are changing every time I hit enter. That's because this is a rand function. It doesn't really take an argument. Rand is just rand with open and closed parentheses. And what it does is it generates a number between 0 and 1. So this is, 0.33. If I just hit enter anywhere in here, let me just change something here, anywhere. See, it recalculates, it gets you a new random number. Rand between, on the other hand, is the same thing, except it allows you to set minimum and maximum values. So here I've set the lowest value to be 0, the highest value to be 100, and let's do this. You can see right now it's got a value of 3, but if we run that generator again, now it's got a value of 34. Now actually, after you do generate some random numbers, it's usually best to copy them and then paste them back in as values only, so it's not going to recalculate on you every time. So there you go. But now I've lost my formula. I'd have to write it again if I wanted to calculate or if I wanted to generate more random numbers. Okay, rounding. Here I've said round to 1 decimal place, so 26.24 is going to be rounded to the nearest tenth, which is here, and yes, that is correct. If this was actually 24.5, it should round up, which it does. Follow standard rounding rules. In this case, the round up function was used. So I'm rounding to 1 decimal place. I can actually say 0. Now it'll get me a whole number. And it's going to take that 26.24 and it rounds up to 27, even though rounding rules would dictate that it would be 26. Okay, that can be very useful. There are times that you really need to do this, especially in practical situations. Okay, next one is the square root. Square root of A14, 137 is 11.7046, etc. I'll take their word for it. Here you go, sum. So now I've just summed all of these values here, and it turns out that they're 462.16. Sum if. I've summed the same set, but only if they're greater than 0. So what that did is it eliminated the negative 23. Everything else is above 0. Now if I did a little quick check here to see if my computer is functioning correctly, I could take this value minus this value, and I'd get the negative 23, so that worked perfectly. Now in this case, the last case, sum ifs, I simply entered the formula. I said these are the cells that I'm dealing with. Okay, A2 to A14. And the rule that applies to A2 to A14, which is kind of odd that you have to put this in here twice, but you do. Anything greater than 10, and then from the same set, anything less than 20. So if I look in here, something greater than 10 and less than 20, well, this doesn't count. The only thing I have in here that fits those criteria is this number 12, and you can see that that's reflected here. So math functions, very useful, as there's a million of them, and you just have to follow the syntax to get them to work. Now logical functions. Let's start with a very powerful one, the if statement. Now if statement lets me return values based on whether a condition is true or not. So here we can see that I've entered some names and the ages of the students, the town that they come from, and whether or not they were on the honor roll. So let's just see if we can add up easily the number of students who are 13 or more. Okay, now there would be other functions we could use for this. We could use a count if for sure. But let's try it this way. Equals if this value in B2, and now, I'm sorry, if B2 is greater than or equal to 13. Now it takes 3 arguments. The first one is the logical expression. So I'm saying if the value in that cell B2 is greater than or equal to 13, I have to do something if that's true. And if it's true, I'm just going to put a 1 here. Now I don't have to put a 1. I could say, I could put some text in here and say over 13. I could do that. But in this case, I'm just going to put a 1. Then I'm going to put a comma, and I am going to put a 0 after that. So basically, you put the logical expression here, then the next thing to follow is what to show in the cell if it's true, followed by what to show in the cell if it is false, if that condition is not true. And in this case, we get a 1. Yes, there's a 13-year-old there. If I were to drag this formula down, you can see that for any of the 12-year-olds, it's 0. Then, of course, I could just sum these up if I wanted, and I'd get a total. Okay, now, why do it that way? Well, because you can also do nest if statements. And what I mean by that is you can put one value if it's true, say, and if it's false, you can put another if statement in there. You can nest up to 7 of these. Okay, so you can keep applying rules and rules and rules to see if it meets all the rules. So let's try it with just 2. So we know that this formula, and here's a technique you can use. If I drag this across, it's going to increment. It's now not going to be looking at cell, here it's looking at cell B2. Now it's looking at cell C2, which is not what I want. So another method you can use to get an exact formula is to highlight it in the formula bar, copy it. Ready? Control C for copy. Then I'm going to hit the escape key so I don't mess up that formula, and I can just come into this one and I can paste it. And I'm getting that exact same formula. It didn't increment for me. So a little trick. Now let's go back into the formula and look and see what it looks like if we nest an if statement. So basically what I want to say is it's not good enough that you're 13, but you have to be 13 and from this town RP. So if you're 13 right now, you get the 1. But we want to do another check, so I'm going to highlight that 1 because I'm going to substitute another if statement in there. If, I'll open and close the brackets there, so I'll set myself all up. If this is equal to RP, and when you're using a string or text, you have to put it in quotes. If that's true, put a 1. Otherwise, put a 0. So this starts to look a little complicated, but let's see what it does. It checks to see if you're 13. If you are 13, it checks to see if you are from RP. So if both of those things are true, you get a 1. However, here, if you weren't 13 to begin with, it gives you a 0 over here. If you were 13 but weren't from RP, it gives you a 0 over here. So when you do that, you can see this student is of 13 years of age and from the town. Let's see how many there are. Here's a kid who's 13 but not from the town. And let's see, all of these 13 RPs show up as 1s. All of these LFs automatically should be 0s, and all of the 12 should be 0s, and they are. Okay, now alternate ways to do that. Now with the if statements, as I said, you can nest them repeatedly. I could take either of these values and nest another if statement in there. It can be very, very useful if you want to do some sort of complex analysis on some data. Okay, and then you have sum ifs and average ifs also that you can use. Let's look at an alternate way to do this. So 13 plus. Another way to do this, and a simpler way in this case, would be to use the AND function, AND. So when you use the AND function, you're saying this is greater than or equal to 13, so same thing I did before. And this is equal to RP true. And you're going to notice that all of the trues line up with the 1s because it did the same thing. And all of the falses line up with the 0s because it's an alternate way to do it. Now, why would you choose one over another? Well, in this case, I might do the if statement because it makes it really easy for me to add, although I could add up trues and falses as well. It wouldn't matter. So the OR statement, let's try this one. Equals OR. In this case, I want to see if they're 13 or older. Is greater than or equal to 13. And expression 2, this is equal to RP, so almost the same formula I had before. Okay, so that's true. But this time it's seeing if either of those things is true, not both. So you can see that some of these that were false, well, this student is 13. They're not from Ridgefield Park. Here's a kid who's 12, so doesn't meet the first criteria, but is from Ridgefield Park and gets a true. And the kids from Little Ferry who are 13, as we just saw, get true also. So in this case, there's only one student who's 12 and from Little Ferry. They don't match either of those criteria, and so they get a false. Now, another alternate way to do this is simply to use the not command. Okay, so instead of saying if something exists, you say if it doesn't exist. So this is equals not so in this case, I'm just saying if they're not from Ridgefield Park. So it's false because they are from RP. Whereas if I copy that formula down, you can see the trues for those from Little Fairy. Now, if you have just two criteria, it makes sense to do the AND or OR. When you have a whole bunch of different values or options, and you want to exclude all but a couple, not makes a lot of sense to do that. Okay, so you play around with those functions, and that will you'll get better at them as you work with them more. Okay, there's things called lookup functions, and we're going to look at vertical lookup, although horizontal lookup works the same, virtually the same way. And then there's a couple of others we're going to look at briefly. Basically, I have a list of students here, and I have their letter grades, what they've earned in the class so far. But what I want, I have their numerical grades. What I want is their letter grades. So I've created this table over here. And basically the way a vertical lookup looks is when I give it the formula, it's going to check down here to see if my formula meets the criteria, and then it's going to stop. Like if my value was 72, it's going to meet it at 70. It's not going to meet it at 73. So I'm going to be able to pull information out of the other columns that are associated with the last case in which this is true. So that probably sounds confusing. Let's take a look. So equals V lookup the search key. So I'm going to search this 96. I am going to search this range of things. I'm not going to include the header up here, just this range of things here. And I am going to return the letter grade. So I'm going to return what's in the third column. And actually, I can't click that. I basically have to say column 3. So column 1, column 2, column 3. And that student has a 96, which is an A. So let's see how that works. They pass all these, they pass all these, they pass all the way down, so they get to the last one. I'm getting a bunch of NAs. Okay, the reason is that when I increment down here, look, I forgot to lock in my values. And what the values I want to lock in are these, the ones for the table itself. I want it to be able to increment and look at row after row after row, which is the first value, but the second set of values, I'm going to change those to absolute references. Okay, now, drag it down, and you can see my grades come up nicely. Let's check this 78 to see what it is. It meets 77, doesn't meet 80, so it's a C+, working perfectly. Now, let's go back to that trick we did before. I'm going to copy this thing out, copy it, hit the escape key, paste it in here. It's the exact same formula, and what I want to do this time is the comment. I want to return the comment over here, so I'm just going to take that from the second column of my range instead of the third. So instead of taking the letter grade, I'm going to take the comment to, oh, look at that. That student got an excellent. When I copy this down, the individual comments come out here. Now, one thing you could use this with, honestly, is a mail merge. So if you were doing a letter and you wanted particular references, you could pull them out of a lookup table and then mail merge that, but we haven't looked at mail merge yet. Okay, so that's basically how vertical lookup works, and it's how horizontal lookup would also work. So the function I'd like to talk to you about now is a function called match. And match is excellent for comparing two lists, finding the matched location, so finding two things that match and letting you know where they are in each list, but also identifying the things that don't match in a list. So here you can see we have the list of names. If I scroll to the right, I have a similar list. Now this one is alphabetized by last name. This one is not. Also, there are some slight differences between the two lists, so let's see if we can find those. First, I'll put a label up here. And now the formula for match is equals, parenthesis, equals match, parenthesis. And now it's going to ask you for the search key, or what you're trying to match. Well, I'm trying to match this person's name. And now the range. Okay, so trying to match that too. And I'm just going to slide over and select this column. Now it doesn't matter that the column ends here because there's nothing below it. So, you know, it'll look through the whole column, but the only values that really count are down to the last one there. And the last thing that you're going to have to put in here is a search type. And for now, just take my word for it. You want search type 0. So that's an exact match, the first match it finds. So there you go. So you see what gets returned here is a number, 28. And what that number is, let's see, this is Umera Zimmerman. If I come down to 28, come across here, look at that. It found the row number of that match. So all I have to do is, well, one thing I have to do is I don't have to make this an absolute value because I've made it K to K, the entire column. If I had selected this list and had, say, K2 to K, 30, whatever it is, I would have had to make that an absolute value so it didn't increment when I pull the formula down. Okay, fantastic. So now I've got the match of each one of these things in this list. Now, I've created another match over here. So equals match. And I'm going to match the opposite way. I'm going to click on this person as the search key and match it up against this list. So there's a difference. There's obviously not the same names in each list because one list is longer than the other. So I'll do comma, and I'll put that 0 in. And you can see here, Sid Beaumont should be in row 10 over here, and he is, so that's perfect. When I pull this down, that's great, but you see I'm going to get a couple of NAs. What NA indicates is that this name is not in that list. Okay, so you can use match two ways. I can identify where in one list a match occurs, or if there is actually no match in the other list. Now, how can this row number be useful to me? We're going to use it in a function called indirect. So what I would like to do with this list is I would like to bring across Sid Beaumont and everyone else. I'd like to bring across their numerical grade. We'll call it their score. Or I could bring across their letter name, or I could bring across their comment, or I could bring across all three. Okay, that wouldn't be a problem. So indirect allows me to take a number and substitute it into a cell reference. Now what does that mean? Okay, if I was going to say please equal, I don't know, C2. Let's see what that does. Well, C2 is the grade. Okay, so if I didn't know here whether this was C2, C3, C4, it was in the column, I could use something called indirect. So I'm going to say indirect, quote, C, if that's the column I want, close quote, ampersand, and then I'm going to pick the number. So this is essentially going to become C10. And you can see that Sid Beaumont, it pulled a B, and he's in row 10 over here. So let's find row 10, Sid Beaumont. Yeah, it is actually a B. So it's a very powerful tool. It might be a little confusing in the beginning, but if you delve deeply into spreadsheets, and you can see that we're going to hit another error here because there is no row number, that's fine. If you dig very deeply into spreadsheets, you will find this, believe me, a very useful function. Okay, just very briefly, I'm going to go over column and row and transpose equals column here of K2, and you can see that that is actually column 11. So A, B, C, D, E, F, G, H, I, J, K. It's the 11th column over. Okay, and if we did that for row, we could say equals row, where am I? I'm row 5 here, so that should say 5, and it does. Okay, these things are useful in conjunction with other functions, like we saw match, how we were able to throw that into an indirect. Well, you can do the same type of thing with row and column, if the need presents itself. The last thing I'm going to look at is transpose. So I'm going to look to change the first 1, 2, 3, 4, 5 of these, and all the associated information here, the match and the score, over to, instead of being vertical, horizontal. So in order to do that, I'm just going to say equals transpose, open this up, and I'm going to select the range. I'm going to say enter, and it knows to put them in the the adjacent cell. So now the labels are vertical, and the data runs across this way. By the way, if you didn't have enough room, you can see that we're up to T here. If I change this transpose to M8, it would just create more space for you, so that wouldn't be a problem at all. Okay, enough of those. Those might not be something you use if you're not used to spreadsheets. They may not be something you use right off, but they are very valuable. They are very valuable once you really get into things. Okay, info facts, the last type, or information functions. Okay, let's do this. This is just telling you the type of data or what exists in a cell, and these can be useful in things like if statements. Okay, so you can say do something but only if the cell is blank or the cell is not blank or something like that. Okay, so here we go. We're going to start with is blank equals is blank. Open that up. Is this cell blank? And the fact is true, it is. So it returns it true if the cell contains no content. This cell does create content, so if I just pull that over, it's going to increment over. It's going to refer to B2, and you're going to say, no, false. That cell does have content. Is error. Now I created an error here by dividing 10 by 0, so I knew that would be an error. And equals is error. Yes, true, that is an error. But the letter X is not generating an error over here. It's just a string. It's just something in the cell. Okay, is NA. This is a specific type of message you get. NA, if you saw in the previous sheet, we got that kind of message when we used the match function and didn't find one. It's not exactly a technical error, but it's something that's not working the way it was intended. So is NA. Of course, we can see that this is NA, so that's true. And of course, you'll get a false if that's not the exact thing in the cell. Okay, equals is even. Is 2 even? True. False, because 1 is not even. Is odd is going to work the same way, except with odd numbers. Is 1 odd? Yes, it is. Is 2 odd? No, it's not. Is number equals is number. And cell A7 there does actually contain a number 5. The text 5 over here, this is not considered a number. I can't add that or divide it, so it's not a number. It's text, even though it represents a 5. Equals is text. Yes, 5 is text. Even though it's telling me a value, I can't add it or subtract it, whereas the number 5 is not text. And then there is a function called isNonText. So you can see this is not non-text, it's a number, but let me copy this. Okay, if it was this, if it was NA, or if it was the result of this error in division, because you can't divide by 0, it would still be true, because those things are errors and they're messages, but they are not text. They're a different data type. So it's just a way to distinguish text from everything else. Okay. In the end, I know that was a lot. That was a great number of functions. I wouldn't expect anyone to be able to know them all, but I wanted to expose them to you because I wanted you to see the range of possibilities. Now, a lot of things we didn't even go into. There's all trigonomic functions and financial functions and ways that you can do compound interest, and there's just a ton more in here. Okay, but I think this is a pretty good sampling of what's available in the spreadsheet and what gives a spreadsheet its power.